video, we're going to show you some of the tools for the science classroom and how to use them. You will find most of these tools in your HSP or your Harcourt Science Kit. These kits for grades 3 to 6 are in all of our elementary schools. The kits contain materials that you would use over and over, such as buckets and dish pans, hot water pots, and other materials that you might use specifically for a lesson.
Some of the tools we have for measuring length are a metric ruler and a measuring tape. In grades 3 and 4, you may want to use the customary system of inches and feet, but in grades 5 and 6, students should use the metric system. Don't stop science investigations just to teach the metric system. Instead, embed the measurement in the activity. Just tell the students to use the metric side of the ruler. The tiny lines are millimeters. 10 millimeters equals 1 centimeter. Just let them measure and use the units millimeters or centimeters. If they're comfortable with decimals, 15 millimeters is the same as 1.5 centimeters.
Make sure that students know where the 0 point is on the ruler. You'll notice in the wooden ruler, 0 is right at the end of the ruler, but in the plastic ruler, the 0 line is indented. To measure liquids, we have measuring cups with both US customary and metric. We also have beakers and graduated cylinders. The units for liquid measurement will be the milliliter and the liter. You'll see the milliliter capacity for the beaker or cylinder noted on the outside. In this case, we have 1,000 milliliters, which is the equivalent of 1 liter. A great reference point for students when using liters and milliliters is a 1 or 2 liter soda bottle. This helps them get a sense of how big a liter is and how small a milliliter is. Beakers are great for measuring out approximate volumes, and graduated cylinders are used when precision and accuracy are important. To use a graduated cylinder, pour in the liquid, and then get down to eye level and look at the curve of the liquid. The bottom of that curve is known as the meniscus, and that is the exact point where you would take the measurement. When you use a graduated cylinder, notice the markings. Those are the graduations. Between 20 and 30 milliliters in this cylinder, each of the small lines is equal to 1 milliliter. To get an accurate measurement, get down at eye level, look at the bottom of the curve, which is the meniscus, and that is your measurement. In this case, it would be 32 milliliters.
Some of the kits have a pan balance, which is to measure mass. Use the term mass instead of weight whenever possible. Mass is the amount of stuff or matter that's in an object, while the term weight actually refers to the effect of gravity on the mass. In other words, if I were on a planet that had less gravity than Earth, I would weigh less, but my mass would remain the same.
So, wait a minute. I'm spending a lot of money on Weight Watchers, and you're telling me I could just lose weight by going to the moon?
No, you wouldn't actually be losing weight. You'd be losing mass with Weight Watchers, and that's much healthier. Now, when you use the balance, the units are grams. The grams are actually stored in the front of the balance, and they're very small and easy to lose.
Jeff, the first time you opened that, the gram weights were actually on the bottom of the box.
That's true. A reference point for students to let them know would be that a nickel has approximately 5 grams of mass.
Some of the other tools that we have for science are called forceps. Get the students using that term forcep instead of tweezers. We also have thermometers, and even though the thermometer may have plastic or metal, it does still have glass, so be very careful in the handling. We also have eyedroppers, and the more scientific term would be pipettes. So the other thing that's kind of interesting is measurement accuracy. It would be great to have a conversation about accuracy of measurement when you compare an eyedropper to a pipette to a turkey baster.
That's true. I think it would also be great to have kids come to a common understanding of what a drop is.
That's a really good point.
So a drop could be just a drop, or someone might call that a drop.
Exactly. So do make that clear to your students.
Now, another common tool that we have is a hand lens. The way to use a hand lens correctly is put it up to your eye and then bring the object into focus. You'll notice that there are two, on this particular hand lens, there are two different magnifications. The smaller one is the stronger of the two.
These tools and the HSP kits, if not in your classroom, should be in your building somewhere. Some schools have kept the kits in the classroom, while others have broken down the kits and maintain a central storage area for science materials. Do check with your coach or principal for where the kits are in your building. All right, so here's an example of the Harcourt Science or HSP kit. Inside the kit, you will find common materials like buckets or hot water pots, even things like funnels and aluminum pans. These are things that can be used across multiple grades or multiple classes. What you'll also find in the kit is individual bags. This is an example of a bag, materials for a fossil activity that aligns with Chapter 8 in the 6th grade textbook and also Unit 9 in our new sequence of units. So these materials, again, in your buildings, make sure to be looking for them and sharing them across classes and teachers. Using these tools will actively engage your students in the doing of science because we all know that science matters.